Hi, hello everyone. Today we are going to discuss about cluster algorithms. This particular cluster algorithms, which we predominantly discussed as a part of our regular workshop. However, we just discussed about two basic algorithm. One is k-means, and second one is that hierarchy based, that is agglomeratory algorithm. Apart from that, there are various other algorithms which we are going to talk about in this demonstration, so that you will get a fair idea about what is different type of clustering algorithms and where and all it will be fit in. So this algorithms is going to run using our classic data set, which is mall customers. Okay. Having said that, let me quickly go to the PPT. The agenda is that I'm going to explain what is clustering. After that, we are going to discuss all these, different clustering algorithms like affinity propagation, mean shift, spectral, HDB, DB, optical, and Birch algorithms. So before getting to various different algorithms, I would like to give a overview, or rather an introduction about clustering. So in this slide, I'm going to talk about what is clustering and what it does, why we are doing basically clustering here. Okay. Hang on. As the name itself clearly suggested, clustering is dividing a data set into a logical grouping. So that logical grouping doesn't have any relationship with the other logical grouping, or will have a less relationship with the other segregated logical grouping. So what we are trying to do here, as a part of this particular image, I have a training set which consists of apple, orange, and a strawberry. After running our machine learning, clustering based algorithms, so what I'm getting a segregation of apple, orange, and a strawberry. Okay. So my algorithm clearly understand what is what, and it was able to predict it, rather segregate it exactly which group each category belongs to. Okay. Now we will just see the content as well. What has been written in this check. This is a process of creating a logical grouping for the target marketing. After identify this clustering group, I would be able to do a target marketing. So in a nutshell, this different clustering group will have a similar data points. The objects within this clustering may or may not have a relationship with the other, even if it has a relationship with the other clustering, it will not have 100% relationship. It has just, I would say 5 to 10% relationship with other clustering. Okay. Next is that we are going to discuss about affinity algorithm. Okay. So the name itself clearly suggests that what is this particular algorithm. So affinity propagation, the literal meaning for affinity is that relation. It's a relationship between more than one entity with the other entity. So what it basically does, it will just send a message between data points until convergence formed. That there are two main parameter which help to control this exemplar. Let me explain quickly. If you look at this particular graph, we have plotted some value on the x-axis side and some value on the y-axis. So if you look at this particular example, we have a data points where the affinity propagation algorithm sends messages from here to here, from here to here, here to here, here to here, and finally it forms one cluster, or rather a prototype or an exemplar, which will be basically, again, it's an exemplar for creation of clusters using the rest of the subset of the training set. Okay. If you look at this particular example, we have just forget about the least close to ones, wherein it also marking at the same point, but we need to just to forget about that. We need to take the data set or the data points which is close proximate to this data point, which send this message to here, 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 and it's form as sphere kind of a cluster. Therefore a cluster is being created when affirmatory propagation sends a message through the data points, and the same applicable for the different clusters. Okay. And in the last slide, what it says, it sends messages from one data point to the other data points, and it creates an exemplar. Okay, that is the responsibility of this particular cluster creation. Okay, and there is something called availability. So based on this exemplar, we have a subset of a training data set which should able to create an affirmatory propagation clustering based on the data set which is available or not. That will be confirmed as a part of available. So basically what I'm trying to say here we are just creating an exemplar. Based on that exemplar, it creates a multiple clusters subjected to the subset of data available from the training set. Okay. So it will just create until a convergence is formed. So let me just go to the next slide and explain with respect to our classic example on mall customers. Okay. So in this slide, we are going to discuss about the actual data set that we received as a part of the workshop. As you aware about the mall customer data set, they're buying a pattern and what is their tentative annual salary, right? So let me just quickly go to the Python code to show you what I have exactly done in terms of affinity propagation, so that you will get a fair idea on what is affinity propagation. So as you're aware about all these codes, what I'm trying to say here, I was trying to import two libraries. One is Panda Smartplot lib. This is for plotting, and this is to handle the tabular data. So after that, I'm importing the data set into my IDE, which is Jupyter Notebook. After that, what I done, I try to identify these two labels. Is extremely important for me to create a clustering. One is what is the expected annual income of the customer, whoever step into my mall, and what is their buying pattern. Buying pattern can be determined based upon the scores which they obtained if and when they procure any material from my outlet. Okay. So based on that, I just put an iLog, and I have taken third and fifth, third and fourth column. Okay, after that, I'm running my affinity propagation algorithm. So once I run that, I'm just predicting what is the value of unlabeled data using this labeled data, whichever we found out, which is basically 3 and 4 column. Okay. After that, I'm just seeing the number of clusters which has been formed here. Okay. I'm just seeing the shape of the cluster. It produces 11. Okay, 11 clusters. After that, I'm assigning with one variable, whatever I predicted. Now I'm just creating a variable called supervised and assigning the original data set, so that I'm seeing what is the original data set, and I need to uncover something out of this data set, which is nothing but what I'm going to uncover in terms of identify the targets. So what I will be doing, I'm just creating a cluster, because as I already told you, I have created a 11 clusters after running affinity propagation algorithm. After I run that successfully, I found 11. Now I'm going to just include that particular column into the existing data set, so that I am getting something like this. Okay. So this is the one which has been created as a part of a running affinity propagation algorithm. And finally, using a Seaborn, I'm just plotting it, and found out this is my data set, meaning what has been uncovered as a part of clustering group. If you look at this particular example, I will take the first one, 0, wherein the customers um, annual income is just 20,000 to $40,000, and they are able to spend 10 to 20% of their total income. However, they have their 80% of incomes within their pocket. And if you look at this particular purple example, wherein the customers able to earn between 85 to 140 k dollars, and their buying behavior is something like they are able to spend 10 to 40 percentage of their total savings. So what I would suggest, we can put up an offers to target this sort of customers to buy them more, and there could be a scenario where they just came into your shop and see the materials whichever they intended to purchase, they just purchase and go away. So what I would suggest is just to put up product bundling. Say, for example, if a target audience come down to the shop to buy a bread, just to put a bundling like along with the bread, put a butter, jam, biscuits, donuts, and make it as a bundling and keep it at a nominal rate, so that this customer would be able to buy more, because obviously these customers are rich in terms of their annual income. So obviously from 20 to 40 percentage of their buying behavior will go up to the extent even 80 to 90%. It's basically the suggestion is that you need to put up product bundling and help them to identify their explicit as well as implicit need. Thereby, the sales of your organization could be gradually increased. That is one sort of value proposition that I would like to give out of this particular graph. Okay. So basically, what I was trying to say as a part of affinity, it discuss or it sends the message, every data points, and then it creates different exemplars. Okay. Next, we are going to talk about mean shift algorithms. So, what is mean shift algorithms? What it does basically, it will just try to identify a blob within a dense of sample. Okay, if you look at this particular example, let me just pull down the marker. If you look at this particular example, we have a smooth dense of data points which has fall here, here, here. Okay, and you try to identify a blob within the same. Let me. So I would say the blob is here, here, here. Okay, and you try to create a cluster within that particular common identical data sets. Okay. So if you look at this particular point, you will able to understand it creates a blob within the smooth dense of sample. It will create a centroid. Okay, and the rest of the candidates around this particular cluster able to be a mean point to this particular centroid, whichever we have plotted here. The centroid is nothing but the blob that we found out here. Okay, so this particular candidates will be pre-processed to eliminate near duplicates, because there could be some outliers. Those outliers and all just removed, and it will just bring in what is the exact mean shift. Okay, this centroid is nothing but what it takes. It just takes the average of the data point is available in this cluster, and it takes each data points and sum up the square of all these data points will give this particular cluster. Okay, again back to our classic example. I just run the mall customer data set and found this particular data set, meaning the output result. Let me just quickly go back to the Python example, so that I can easily correlate what is what mean shift algorithm. So I hope you remember all these codes. Okay, I try to download the data set, and then I'm trying to run mean shift algorithm. I'm just passing a hypertuning parameter, so that I can able to ascertain what is the best possible result that I can obtain out of this particular algorithm. And then I'm trying to identify the cluster center point on which I got 131 points, which is nothing but the blobs which we discussed in our previous slide. After that, I'm just predicting based upon the x. The x is nothing but the annual income, and the purchasing pattern, which is nothing but the score obtained by the customers. After that, I'm just plotting it to the original data set and adding that cluster into the original data set. Thereby I got this value. So this is something which we found out based upon our mean shift algorithm. And if I try to plot them in a graph, I'll just show you what is what. I just imported a Seaborn graph. Okay, so this is my graph behavior. Okay, so let me just give an actionable insight over this particular graph is that so if you look at this particular data set, the green ones, these are all one cluster, this one cluster, this one cluster, this one cluster, this one cluster. Okay, and it creates a point which is I would say that this is the point which is a centroid, which is basically uh, being assigned as a centroid, and it calculates the mean for each data points and it forms this particular cluster. The same is applicable for every cluster whichever we predicted and being shown in this screen. Okay, in case if you have any question, feel free to ping me or bust me, so that I would be more than happy to assist you to give more example about this particular code or this particular deck. Now we are going back to our slide. Okay, this is all about mean shift algorithm. Next is that we are going to discuss about spectral algorithm. Spectral algorithm, what it says. Okay, so it's a roots in the graph theory. It connects the edges. Basically, it will connect the edges, which is called a node. From that node, it will create what you call a tree kind of a concept, using which it will plot the clusters. Okay. So unlike your k-means, you don't have to explicitly say what is the cluster that you need to obtain. It will take care by itself after running the algorithm using a Python Jupyter notebook. Okay. And the important point that I would like to emphasize here in this spectral algorithm is that um, it not only help to form the cluster using the graph based data. It also help to form a sphere or a fixed line using non graph based data as well. That is the sophisticated features using this algorithm. Okay, so if you look at this particular example, we have used mall customers data, and this mall customers data we just plotted. We got two cluster, one with blue and the another one with a saffron. And if you look at this particular point, the cluster do not follow a fixed shape. Points that are so far away but connected belong to the same cluster, and the points which are less distant from each other could be belong to a different cluster if they are not connected. So if you look at this particular cluster, the blue points which is scattered, and it's just gone to the saffron line as well. Okay, however it is still part of the blue color cluster. And if you look at uh, the saffron ones, it's created a cluster, and the data points here, which is also scattered here, 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 here. But what it takes a fixed value and just eliminate the rest of the noise in the data sets. Basically, it's an outlier or an extreme value that has been found by this algorithm while we execute Python code using the mall customer data set. Now, I would like to take you to the source code. I would just give explanation about what is spectral clustering. Just give me a second. Let me open up. Okay. Uh, Spectral clustering. So spectral clustering, once again, let me just remove this scribblings, what I have done. Okay. Okay, as you all aware about the steps which I have showed in the previous affinity propagation and the mean shift algorithms. Okay, I will just to quickly go to the area where we tweak the logic using spectral clustering algorithm. Okay, and I assigned a few you know hypertuning parameters to identify if at all I'm getting a best possible results. I'm getting two clusters. I'm just trying to identify the output value. I got okay two. One is zero and another is one. Using which I'm creating the cluster column within the existing data set. Let me just tell you what I have done exactly. So in the original data set, we don't have this particular column. After running this particular spectral cluster algorithm, we got this output value, which we already told. We got two value. One is 0 and 1. In this example, you would be able to see that that has been proportionately passed on to the annual income and the spending score. So we got this plot something like this. Okay. And I would like to show a pictorial representation of this particular graph in the following slide. And this is how it looks like. Okay. The same example which has been copy pasted into the PPT and explained in the deck itself. So I don't think any more explanation would be required for this particular spectral clustering. If at all you have any questions, feel free to buzz me so that I would be more than happy to assist you. And the next algorithm that we are going to discuss is that DB scan algorithm. Okay. So let me just quickly go to this DB scan algorithm and clearly explain what is what. So the expansion for a DB scan algorithm is that a density based spectral clustering of application with the noise. Okay. When we say noise, noise is nothing but I would like to give more clarity about this particular term. Because if you look at any data set, we have extreme value. Okay. Extreme values are called outliers or noise. When it comes to a k-means or hierarchical algorithm, which is agglomery algorithm, it doesn't take care of those noise or extreme values, because those value will be part of our original data set or training set. So those algorithm will not able to ascertain the exactly what is what. So as a part of DB, that is density based special spectral clustering of application with the noise able to identify. Okay, let me just quickly tell you what is it is. Okay, suppose we have a circle. The epsilon value is 3. Okay, now in this circle I have, this is the base point. I'm sorry, I'm bad in writing. Okay, and since I give the epsilon values 3, so I have one more data point here. I have one more data point here, which means this is my cluster. This is my the what do you call equator scalar. So if I have another data point here, let's say I would call it as A, B, C, and then I have D, and then I have E. Okay, these are all the different data points that we got as a part of sampling. Now we got this data points. This is the central point, and if I plot one more radius, I got data point 1, data point 2, data point 3. Now what it says, this is also part of my DB scan clustering because it satisfies my condition. I got 3 data points because my epsilon is 3. Again, if I put like this, I got 1, 2. Okay, then it will not give the desired result. If you look at this particular point, which is a boundary point, okay, and this particular point is like end of that particular cluster. Okay, so now when I plot this in a graph, I'll be getting something like this. So I'm sorry, I was trying to put a dot but could not. Okay, all those will be in this cluster or basically considered as a DB scan. Okay, so whatever the data which goes beyond this are considered as my noise, which is extreme values or outliers. So there is a possibility of credit card transaction that this outlier will behave differently. So which has a potential behavior where the user may face credit card fraud, or in case if a flight will land into a water or not, that is also can be ascertained using this noise. Okay, in case if I'm unclear, feel free to buzz me. I can help you to clear out all these examples. Having said that, we will just quickly go back to our db scan python coding so that you will get a fair idea what I was trying to say. uh, db scan clustering, I hope all this you ever. I'm not going to take you through again. Instead, directly I will go to the algorithm. Okay, so this is the algorithm db scan. So as I told you, epsilon value is 3 I given, and the minimum space is that in this example I gave 2, because within that circle I wanted to identify bare minimum 2 data points using which I would be able to create a cluster. Okay, so in this example, what I have done, I just predicted the value. Okay, now I got around 30 values right from -1. Okay, let me try to plot it in a graph. Okay, so you'd be able to see it starts from -1 and keep going until 30. Okay, and then it just plotted a graph something like this, as I already discussed about this in the PPT. So what it does, it creates a cluster here, 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 here. So basically, it will create a cluster based upon the EPS value and the minimum, data points which we need to plot it. So based on that, it will identify the data set, and whichever it goes beyond this data points are considered to be an outlier. Okay. Okay. All right. Let us go to the deck, and then we will discuss about a few more clustering algorithms. Next, we have HDB scan. HDB scan, which is an extension of DB scan. Okay, so it's basically in a hierarchy, dense-based spectacle clustering of application with the noise. Okay, so what it does basically, it will just um, if you look at the traditional DB scan, what it does, it creates a cluster. It found out a noise that is the extreme value, but it will not able to ascertain the cluster using a different or heavy data set. Therefore, to aggravate that particular problem, we brought in one more logic called HDB scan, which alleviates the assumption and explore all possible density scale by building an alternate representation of the clustering problem. So what the DB scan does, it just identify the circles That is the clustering with the EPS value that whatever we give, and it identify the minimum points whichever we gave as a part of input parameter. But it will not tell us exactly what is the outlier value and how far the value is go beyond with the original data points. So to uncover that particular thing, we need HDB scan, which basically take all the combination and it plots a graph. Okay, so if you look at this particular graph, if you see this, it will take all these data points into consideration. Okay, let me just to go back to the Python code to explain about this. HTTP scan. Okay, so as you all aware about this code, so what I'm trying to do, I'm trying to create the clustering algorithms here. So there are various playable parameter available for this HDB scan. So in this example, I have just chosen algorithm ball tree, and the minimum cluster size is 20. Okay, so once I try to run this, the model has been created, and I'm trying to see what has exactly happened against the model. It's just created one value which is -1 among all cluster. Okay, because it takes every data points as an equal importance, and it covers even the outliers that is shown in the data points. Okay, so when I plot this particular graph, if you look at DB scan example, we had points here, 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 and even it pointed the outlier value, something like that. But we don't know exactly what is what. When it comes to HDB scan algorithm, it just give equal importance to all value, and it creates the entire data set into one common cluster. From there, we need to give an equal importance to all customers to bring them into potential uh, able to buy more products from our company. Okay, next we will move on to this slide. Next we will be discussing about optics clustering. So optics clustering, what it does and what is the expansion for this optics clustering is that it's ordering points to identify cluster structure. Okay, this clustering does not explicitly segment the data point into the cluster. It provides visualization of reachability distance using the cluster. Okay, so what you are trying to say here, it doesn't create any cluster as such. Rather, it just create the reachability of distance. Say, for example, in this case, we plotted epsilon value is 6 and minimum point is 5, and the core distance is 3. Okay, so having said that, this is the core distance from the radius. So it takes into consideration 1, 2, 3. Okay, 3 data points, and 3, 4, 5, 6. Okay, so totally we have 9 data points here. So in this data points, this is the core distance, whatever we are seeing. I'm sorry, let me take a different color. So this is the core uh, point, that is core distance. So whatever we are seeing in the boundary line, which is uh, not a core distance as such. Okay, so when I imply that epsilon value is 6 and the minimum point is 5, this is the my core um, core circle. So with this I can identify what is the reachability distance. To discuss about the reachability distance, I will just go to this other graph. If you look at Q and P, I'm getting a 7 millimeter. So this is the reachability distance. Okay. And similarly, if you look at R and P, this gives me just a 3 millimeter. However, I can clearly say that this is my core distance point or circle, and whatever we are seeing beyond this core circle point, though although it has a two circles, but the second one has some data points which is not a core distance circle as such. Okay, so it's just a given visualization of reachability of distance, and thereby we can implicitly say this itself a cluster. Okay, okay, all right, then we can go to our Python code. Optics clustering. Okay, as you all aware about this code, I will just go to the logic part alone, that is the algorithm part. I just chosen a optics min value and fit into the module, and then I created the core distance. This is for my understanding purpose. Okay, now I created predicted a value which starts right from -1, and it keeps going until I think 58, if I'm not wrong, or at least 57. Let me just go to the, okay, in gone till 57. So if you look at this particular example, or if you look at this particular graph, what it trying to say is, it just created a visualization. Um, oops, just a visualization. It's created here, here, here. It's just to show the readability, meaning the reachability of data points. Okay, here, here, here. Okay, so you can just able to understand by the parameter whatever I set in this program. So I just, the minimum expectation, the minimum sample that I inputted is 2. By default, it will take a 5 EPS value. However, the comparison of samples is minimum 2. That's why the reason is just compare something like this. So if you look at this two, this two, this two, this two, okay. Obviously, it will just avoid the noise in the data set. If you look at this one, this is the noise, this is this point, this point, this point. Okay. So we need to focus on those customers. We need to identify why those points are, completely different from the distance. We need to actually deep dive and understand their behavior, why they are not, coming to our, what kind of strategy that we can do to bring them forward, or club it together with any other potential cluster to be able to make them buy more. Okay, okay. And finally, we have one more clustering called burst clustering. So using burst clustering, what it does, it will just take the root and it will create a line. From that line, it will create a subcluster like this. Okay, what are we are seeing? This is a subcluster 1, 2, 3. Okay, from line 1, we have this many sub. From line 2, this many sub. From line 3, this many sub. Okay. So let me just go to the text part, and we can understand what is uh, balanced interactive reducing cluster using hierarchy. Okay. So it builds a tree-based structure with the cluster centroid at the leaf node. It can also be used to accelerate other cluster method like k-means and Gaussian. Let me just quickly go back to the code to identify what is what in terms of birch clustering. So I just ran the data set. I just got into this particular algorithm, birch. The cluster is none because I do not want to determine myself. Let system take care of the clustering determination part. So I created the labels. So this many subcluster I got 177. So this is my predicted value, and then I'm trying to what you called map it with my original data set. This is my cluster group. Okay. So after that, what I'm doing, I'm just trying to create a graph. In that graph, I created a cluster. It starts from 0 and it keeps going on until I think it should be 177. Okay, it starts from 0, supposed to be 176. Okay. So what I'm trying to say in this Birch clustering is that it will just create a reachability distance. Mm, let's say this is one cluster, this is one cluster, this is one cluster, this is one cluster, and this is one cluster. So end of the day, what it does, it will just based on the EPS value, epsilon value, and the minimum feature, it just take the comparison and just to give the distance between the data points, and it just a form. It wouldn't say explicitly this is the cluster as such, but mere seeing the data, mere comparison of these data points, we can say that this is the reachability distance of data points. Okay. I hope I'm clear with this PPT. If at all you have any questions, feel free to ping me or you can WhatsApp me at any point in time. Okay. All right. Thanks everyone for listening my PPT. Uh, Beyond this topic, I don't have anything. I just have curious to get as many questions from you as possible. Thanks everyone. Have a lovely day. Bye bye.